Ready to be bored. All right, welcome to Physics 121, Introduction to Newtonian Mechanics. This is calculus-based physics, first semester. So here's the course description. Physics 121, Introduction to Newtonian Mechanics, I just said that. 3 credits, fall and winter. The course is designed to meet the requirements of science majors. An excellent understanding of algebra, trigonometry, and calculus. What I mean by that is introductory differentiation and integration in one semester, college calculus, is required. Concurrent registration in the lab is strongly recommended. So here are the entrance requirements. Number 1, Math 212, 1 semester of college calculus. 2, either high school trig or Math 111, which is trig. And 3, passing a comprehensive math exam during the first 2 days of the semester. And a sample math exam is available in Canvas. And this should not be a surprise since I've been emailing you this information for the last 2 months. Okay, you have to take the 121 math exam Wednesday, September 2nd or Thursday, September 3rd before midnight Hawaii time on Canvas. So here are the rules for the exam. No calculator. You don't need it. It's a closed book exam, so no notes, no help from somebody else, no help from the internet, no help from the math lab or the math book or anything. You just do it on your own. You may not share the questions with another person. So yeah, pretend you are in the BYUH testing center. Okay, I think I'm going to make this 3. We'll see. It's going to be timed, so you either have 2 hours or 3 hours. I haven't made up my mind yet. You may be monitored by Proctorio. That's one of these remote proctoring services. I haven't made up my mind on that yet either. The exam consists of 20 problems. Each problem is worth 5 points. Check your work and do well. Number 6, check your work. Really? I promise you, if you don't check your work, you're going to get certain problems wrong because I designed it that way. You have to get used to checking your work if you're going to be in any kind of a math, science, engineering, anything like that. You have to check your work. If you're a doctor, you don't check your work, people could die. So check your work. Okay, why do I do this? So the first few years I was here at BYUH, approximately 40 to 50% of the people in physics were getting D's and F's, which is horrible. And we looked at it, and it was pretty obvious. The reason people were doing so poorly is because they couldn't recall the math that they had supposedly once learned. So I do this because if you can't do math, you're going to really struggle with physics. So this is just to motivate you to study and relearn the things that you've forgotten. That is really that simple. All right, let's see. What is physics? What is physics? It's a fundamental science. It's the foundation for biology, chemistry, astronomy, oceanography, on and on and on. I used to teach astronomy, and I would come into class the first day, and I would say, welcome to applied physics, because that's what it is, really. Physics explains how the universe works. And that means us too, right? Because we're part of the universe, you know? So how the universe works. Here's a really awesome quote from Albert Einstein. The most incomprehensible thing about the universe is that it is comprehensible. We just have to figure it out. Physics is based on experiment. That's very, very important. So if somebody comes up with this beautiful mathematical idea to explain something, but in fact it disagrees with the data, it's junk. Or let's be polite, it needs to be revised. Here's another great quote. Richard Feynman, he was a genius. He came up with his own way of doing quantum physics. He said, "We are trying to prove ourselves wrong as quickly as possible because only in that way can we find progress." Now that's an incredible attitude, right? Trying to prove ourselves wrong as quickly as possible. But that's what we're doing. I mean, Einstein came up with relativity in 1905. People are still doing experiments to see if it doesn't apply at certain, regions or whatnot. Most of you have served missions. Just think back to your mission days when you were teaching the law of tithing. What did you tell the investigators? if they ask, how can I gain a testimony of tithing? What was your response? Do it. I mean, that's kind of like doing a scientific experiment, right? You're paying tithing, and you're going to see the results. All right. Why do we study physics? Well, you know, progress in physics has led to many technological medical breakthroughs. Electronics, NMR, CT, computers, cell phones, nuclear medicine, remote surgery, on and on and on and on and on, okay? So basically, you have to understand the basics of science before, you know, you can use those basics to make wonderful discoveries. It's also a fact that law schools and business schools love people that have studied physics. Why? Well, because when you study physics, you know, hopefully you improve your problem-solving skills, your reasoning abilities, and, you know, that's what they need, right? They want, you know, like the business world, they like to be able to make predictions. They like to be able to model things. Problem-solving skills, reasonable thinking, that's law, right? That's law. So there's many, many opportunities for physics students. Here's just, maybe some of you are thinking of becoming a teacher, a high school teacher. So in 1998, we lived in Illinois, Glen Ellen, Illinois, just average middle-class suburb of Chicago. That year, the high school teachers went on strike. Now, in the United States, we have something called the Freedom of Information Act. That means if you're a government employee, you know, your salary is available to everybody. So they published all the salaries of all the teachers in the newspaper. And we were kind of surprised to find out that our daughter's physics teacher, he had 20 years of experience, he had a master's degree, he was making over $100,000 a year as a public school teacher back in 1998. So, you know, a lot of people have this idea that if you become a teacher, you're going to be poor the rest of your life. That's not true. You just have to teach at a place where they pay well, that's all. Okay, yeah, this is kind of interesting. So this is Henry Eyring. This is President Eyring's father. Henry Eyring was a world-famous chemist. He was at Princeton when Einstein was at Princeton. And then later on he left and went to the University of Utah and basically built up the science program at the University of Utah. So world famous, he was a theoretical chemist, so he did a lot of math, right? Let's say he was a pseudo-physicist, just kidding. Henry Eyring believed that the world his children would eventually live in would be a technical one, where physics was the underlying science and mathematics was the language. Now, because he felt so strongly about that, he somehow, I don't know, had his children, every one of his kids, had to major in physics as an undergrad. After they received their bachelor's degree in physics, they could do whatever they wanted to do. So, for example, so here's an article about President Eyring. This is in the Ensign in 2018, written by Elder Holland. So here's a little timeline for President Eyring. 1955, graduated from the University of Utah with a degree in physics. And then he went to business school and so forth and so on. All right. Physics is required for all sorts of majors, right? Biochem, biology, certainly medicine, computer science, on and on and on. And sometimes, you know, students who want to become doctors, they ask me, why do I have to learn physics of all things? So here's an email I received from a former student, Sonny Martin. He sent this to me during his first year of medical school. He's now an emergency room doctor in Massachusetts, so he became a doctor. All right, aloha, Dr. Weber. It's Sonny from your BYUH physics classes. So I am about halfway through my first year of medical school, and I have been thinking about your classes a lot. Don't ever let pre-med kids trick themselves into thinking that physics isn't important as a doctor. We have recently been studying heart and lung physiology, and the models we use for blood and airflow are exactly the same as the models used for electric circuits. And then he goes on and on. You can read that on your own. So here's what I'm trying to say. In Physics 220, we learn about electrical circuits, how to analyze a circuit, you know, with wires and resistors and batteries and capacitors and inductors and all that. And you know, I can imagine some of the students saying, what do I care? I'm not going to be an electrical engineer. What do I care? But here's the important thing. The same models we use for that are used in medical school. So I think when you're studying physics, you've got to keep the faith. You don't know when whatever you're studying is going to be used later on. I mean, wouldn't it be great if we all had a crystal ball, you know? So just keep the faith and learn it. It will bless your life. If nothing else, you'll improve your problem-solving skills, which will all employers value highly. Okay, let's see. All right, so many of you are going to go to graduate school or professional school, you know, dental school or medical school or whatnot. And so you're going to be, you know, competing against people from all over the country, right? And so, you know, you want your application to look good, obviously. So here's something you want to consider. So let's say you want to go to medical school. So medical school usually says, you know, the minimum is 2 semesters of physics. Okay, now here's the question. Do you want to just do the minimum, or do you want to do more than the minimum? I mean, remember, you're competing with people from all over the country. And so if you're just doing the minimum, whoopee, that doesn't look so great, right? So I mean, I'm exaggerating a little. Do you want your CV to say that you took underwater basket weaving? Or do you want your CV to say that you took calculus and calculus-based, you know, calculus-based physics and stuff like that? So think about that. Don't just do the minimum. That's not impressive. Okay, so here we are. So at BYUH, we just have 3 calc-based physics courses. So 121, this course is mechanics. 220 is electricity and magnetism, incredibly important for medical school. And actually, they all 3 are, sorry, but it's true. Physics 221, waves, quantum mechanics, relativity, atomic and nuclear physics. Important for medical school, especially this, nuclear physics. So you have to take 121 first, and then it doesn't matter. You can either go 220 or 221, doesn't matter. And of course, there's a lab associated with every class. And I highly recommend you take the lab, even if it's online. You'll learn a lot, and it will help you hopefully improve your class grade. What will you learn in Physics 121? Well, you know, you're going to learn a lot of concepts, right? Physics concepts. You'll learn that from the textbook and also hopefully class, right? Concepts. But you're also going to learn problem-solving skills. You'll learn that from the textbook, the class, doing problem sets. There's been a lot of studies of what kind of skills employers want. And they want their employees to have problem-solving skills, because that's what the world's all about, right? Problem-solving skills. Okay, now I'm going to go on a little speech now about problem sets. So pay attention. Okay, so you're going to have problem sets assigned at the end of every chapter. I promise you, you can find the answer, in fact, the complete solution to every single problem I will assign on the web. If you search the web, you'll find a solution. Don't do it. Don't cheat yourself, because that's exactly what you're doing. You're cheating yourself. If you just look up all the solutions, you'll never develop the problem-solving skills that you should be developing. The problems I assign, you should be able to solve nearly every single one by yourself. If you can't, don't go to the web. Talk to one of your friends in the class. Contact a tutor, contact me, but don't look up the solution. Don't cheat yourself. So a former student recently sent me a question from the MCAT test. And it's a full page, actually it's a page and a half. And so the first page, there's just a bunch of text, including equations, that talk about sound and ears and all sorts of stuff. And then there's like a bunch of questions on it. And the questions are not trivial. If you're not good in solving problems, and you're taking like an MCAT or a DAT or something like that, good luck. I mean, good luck. You will not do well. In order to prepare yourself for these exams, you have to develop good problem-solving skills. So work those problems. Don't take the easy way out. Don't cheat yourself. And you're also cheating your fellow students, right? Because you're getting a grade that you don't deserve. Okay, so there's a Physics 121 student in a rocket ship. So we're going to move rapidly in this class. And it's not just because Brother Weber's a nutcase. I mean, we're going to move just as rapidly as any other physics first semester calc-based physics class in the country. It just, you know, there's a certain amount of material you got to cover, and we're going to do it. So here's the, if you want to succeed, you got to keep up. You got to keep up. If you fall behind, it's very, very difficult to keep up. Now, you know, this is online, so I have all the videos on YouTube. If you're wise, and if you want to use your time wisely, you should always do the assigned reading in the book before you watch the video. Don't do it the other way around. Read it first, think about it, and then watch the lectures. That's very important. Hopefully, because I'm not going to talk about every little thing in the book, right? I'm going to pull out the important things. So you read the book first, get introduced to it, think about it, then watch the video. Hopefully it will make sense by then. Reading with physics books is kind of like reading Isaiah. When you read Isaiah, you got to read it slowly. You got to think about it. You might have to reread it once or twice or however many times. It's hard, you know. When you're reading your physics book, if you don't understand a section, you shouldn't just go on. That's kind of silly. You should go back, read it again, think about it. You know, you might even have to, I don't know, look up Khan Academy. You know, there's other resources. There are videos in the textbook, right? If you have the online textbook, there are all these links to online to videos. The textbook has these questions called stop to think. So you read it, let's say you read a page, and there's a stop to think question. So the question is just designed to see if you've understood what you've just read. You should always answer those questions and check your answers. They're in the back of the book or back of the chapter or something. If you get the question wrong, it means you didn't understand what you read. So go back and figure it out. Figure it out. That's the important thing. During class, I call this class, right, my lectures, you know. During class, I'm going to put these multiple choice questions on the screen. And I'm going to ask you to vote on the correct answer. Now the next slide has the answer. Don't look at it. Again, you're trying to force yourself to think. You're trying to develop problem-solving skills, thinking skills. So don't look at the answer. You know, use what you've learned in class and in your reading and answer the question based on your knowledge. Don't just cheat. One thing about physics, it's not about memorizing. Not at all. It's about understanding. Sometimes students, after the first test, they say, I never saw that question. Well, of course you never saw it. I'm not going to give you a question you already saw, but the concepts are the same, and you have to be able to figure that out. Quickly, how to prepare for exams. So I have old exams on the web page, on Canvas, with the solutions, so you should study those carefully. Again, don't memorize, total waste of time. What you want to do is understand. I would recommend that you study and understand every single problem that I assign on the problem sets. You should review the PowerPoint slides. So in addition to these videos, I also have all the PowerPoint slides. So the PowerPoint slides are on Canvas, the videos are on YouTube. Obviously, review the textbook, and you know we have labs. Hopefully you'll be taking the lab. You should review the lab, because why do we have labs? Helps you understand the physics. So review the lab. Okay, I don't want to review, oh yeah, the book. Let's talk about the book. So the author is Randy Knight. Randy Knight is an expert in something called physics education research. So nowadays you can get a PhD in physics education research. What these people do is study how people learn physics. So he's an expert. So he wrote the book based on his knowledge of physics education research. So it's a really awesome book. Let me just show you a couple things. All right, so this is what I was talking about earlier. So you read all this, then there's a stop to think, multiple choice question. Do them. Make sure you do it. There's all these example problems. Don't just be lazy and read them. when you're reading them, take a piece of paper and pencil and go through it, because there might be some conversion, or who knows, there might be something that you're just not familiar with. So actually work it out. You'll learn a lot from that. He has these notes, incredibly important, just these little notes now and then. Make sure you read them. I mean, like this one. Omega is positive for counterclockwise motion, negative for clockwise. If you don't get that right, good luck. I mean, you're going to get the problems wrong. So, all right, he has these really neat problem-solving strategies. We'll go through these in class. You know, some people, they just go haphazard, right? They're trying to answer this problem. They just kind of have this haphazard, crazy approach. Well, here's a systematic approach where if you follow it, it's highly, highly likely that you get the problem right. Okay, I'm going to talk about dress and grooming standards. Now, you might think, why? I'm at home. Well, you sign the honor code. Honor code applies off and on campus, so I'm going to go through it because it's important. So now this is President Sister Tanner. I know they're not here anymore, but that's okay. I'll read it anyway. I believe that all of us gain the power to act in holiness as we learn to keep not just our covenants, but all our promises. This is why I feel so strongly about following the honor code. For me, it is about becoming a promise keeper. We cannot become a Zion people if we are a group of promise breakers. The honor code also contains commandments like chastity and the word of wisdom, and rules like no beards. Once you agree to live by these rules, to break them is to break a commandment. The commandment to be honest and to keep your promises. Disobedience and holiness just don't mix. So you may have seen this around campus when you were here, right? Dress and grooming standards on and off campus. And here's a nice little paragraph so here's a book, The Life of Henry B. Eyring, President Eyring. And he was a real good, he is a good journal keeper. And he used to be the president of BYU, Idaho. So here's something from when he was a president at Idaho. At 7:30 this morning, I met with a young student. He challenged the rules for having guests only at certain hours in our housing. I hope he felt and understood my message. The rules remind him of real danger, and the exact hours become important not because they're perfect boundaries, but because we need to become perfect in exactly doing what we agree to do. So let me explain that some more. Before every student comes to BYU Hawaii, they sign an honor code. Then they go over the honor code with the bishop and the state president. So they agree to keep the honor code. So if they don't keep the honor code, they're basically not keeping their promises. And that's the important thing. It's not important whether or not there's a rip in my pants or something crazy like that. What's important is we made a promise not to wear pants with a rip in with a rip in them or something like that. All right, we're going to have a tutor. I'll send you that information later, and I'll send you his or her schedule. But we will have a tutor. We're also going to have Zoom meetings. I haven't figured out how many yet, because I know people live all over the world. So we'll probably have like one really early in the morning and one really late at night. And the reason for the Zoom meeting is because, when you're watching my lecture videos, you don't have an opportunity to ask questions. So the purpose for the Zoom meeting is for you to ask questions. That's really why. Let's see. Here's your assignment. Why am I okay? So read the syllabus. I already sent you that. Check out the class website. You'll have to take the test the first day or the second day of class. Read the textbook's introduction. It's useful. And keep reading chapter 1. Make sure you read the syllabus. That's important. And, and that's it. Thank you very much.